Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules.
Welcome to Lesson 9, Unknown Angle Proofs, Writing Proofs. Before we get started on this though, there was a link to a video on Sherlock Holmes figuring out a crime. So we're going to watch that video before we continue.
All right. It is nothing. Here, sit down here. Let's have a look. Oh, it doesn't look too bad. Who patched you up? The police doctor? Yes. He looks as if he'd been attacked. Obviously, my dear Watson. Dr. Tobel, do you suspect the woman of arranging the trap? Woman? What woman? She's blonde, 5'6", full-lipped, and very affectionate. Oh, really? You've known her for a long time. You were attacked after leaving her apartment. Holmes, how do you know this? The face powder on your coat tells me of her height and her affection for you. You held her close before departing. Close to the hole? It's all there for the trained eye to read, Watson. But look here, why couldn't he have been attacked on his way to the woman's apartment? The mark of a blow has erased some of the powder. Obviously, if the attack came first, the powder would have remained undisturbed. On the full lips? That was a guess. I never guess, Watson. You have rubbed the lipstick from your face with the handkerchief you now hold in your hand. And that amount of lipstick never came from a pair of thin lips. And the blonde hair? Oh, gracious me.
Okay, so now that we've watched that video, it says one of the main goals in studying geometry is to develop your ability to reason critically, to draw valid conclusions based upon observations and proven facts. Master detectives do this sort of thing all the time. Take a look at Sherlock Holmes, as Sherlock Holmes uses seemingly insignificant observations to draw amazing conclusions. Could you follow Sherlock Holmes's reasoning as he described his thought process? All right, so discussion. In geometry, we follow a similar deductive thought process, much like Holmes uses to prove geometric claims. Let's revisit an old friend, solving for unknown angles. Remember this one? You need to figure out the measure of A and used the fact that an exterior angle of the triangle equals the sum of the measures of the opposite interior angles, or remote interior angles. The measure of angle A must therefore be 78 minus 42, which is 36 degrees. Suppose that we rearrange the diagram just a little bit. Instead of using numbers, we use variables to represent angle measures. Suppose further that we already know that the angles of a triangle sum to 180 degrees. Given the labeled diagram to the right, can we prove that x plus y equals z? Or in other words, that the exterior angle of a triangle equals the sum of the measures of the opposite or remote interior angles. So here's the proof. Label angle W as shown in the diagram. So if we label W, the one unknown angle, or unnamed angle, in the triangle. So then we can say the measure of x plus the measure of angle y plus the measure of angle W equals 180. So that's x plus y plus w, the three angles. That's the sum of any angle measure. Sum of the angle measures in a triangle is 180 degrees. It's a triangle sum theorem. Then we can say the measure of angle w plus the measure of angle z equals 180 degrees. And that is because linear pairs form supplementary angles. So we knew those two facts. So now if we say the measure of angle x plus the measure of angle y plus the measure of angle w, x plus y plus w, since they add up to 180, then we can set that equal to the other equation. See how these two angles equal 180? So let me do some color coding here so it's not confusing. It's the transitive property. So if this is equal to 180 degrees, and 180 degrees is equal to this, then the first is equal to the third, basically. It's a transitive property. So if the red equals green and green equals blue, then red equals blue. So therefore we can conclude the measure of angle x plus the measure of angle y equals the measure of angle z. And where we get that is, if we subtract w, let me get rid of these circles now. Okay, if we subtract w from both of these angles, I can just cross them out. So here's the measure of angle w. So if I subtracted that from both sides, it's gone. So then now we have the measure of angle x plus the measure of angle y equals the measure of angle z. Okay? And that is subtraction property of equality. The other one was substitution. Okay, here's page 2, and it says, notice that each step in the proof was justified by a previously known or demonstrated fact. We end up with a newly proven fact that an exterior angle of any triangle is the sum of the measures of the opposite interior angles of the triangle. This ability to identify the steps used to reach a conclusion based on known facts is deductive reasoning, i.e. the same type of reasoning that Sherlock Holmes used to accurately describe the doctor's attacker in the video clip. So here's an exercise, 1 through 6. So it's writing proofs. So it says, you know that angles on a line sum to 180. So that's a given fact. So I'm going to underline that. Angles on a line add up to 180 degrees. It says to prove that vertical angles are equal in measure. Make a plan. What do you know about angle W and angle X? Okay. Angle W is here. Angle X is here. They are on a straight line. Right here. So looking at this, it says angles on a line sum to 180. So now we can say angle W plus angle X equals 180 degrees. What about angle Y and angle X? Or Z? Y? What do you know about Y and X? Oh, Y and X. Well, here's X. Here's Y. And we have another straight line that they are on, right there. Okay, so if I erase this, and now just focus on here, there's the next set of straight lines. So what do we know about angle Y and angle X? Well, angle Y plus angle X equals 180 degrees. And I should say the measure of. Okay. Okay, so what conclusion can you draw based on both these pieces of knowledge? Okay. And here's the key. This has an angle X. This has an angle X. If we got rid of them, then the other piece is equal to 180. In other words, if I gave angle X a value, it's obtuse, so let's say it's 100 degrees. If angle X was 100 degrees and I subtracted 100 from both sides, then angle Y would be 80 and angle W would be 80 because 80 plus 100 is 180. So we can say the measure of angle W equals the measure of angle Y. So now I can say W is equal to Y, so that's why they only have one mark and X has two. Now write out your proof. So you would say the measure of angle X plus the measure of angle W equals 180 degrees. Okay, that's this here. And then you can say the measure of angle X plus the measure of angle Y equals 180 degrees. And the reasons, we have to give reasons when we do proofs. Okay, linear pairs form supplementary angles. Linear pairs form supplementary angles. Okay, and then the next step would be I'll do it in a different color. Now we would say the measure of angle W plus the measure of angle X. Actually, I'm going to put it in the same order. So we're looking at this line. So now we can say the measure of angle X plus the measure of angle W equals this. The measure of angle X plus the measure of angle Y. Since they're both equal to 180, they're equal to each other. You can call that two different things. Okay, you can say substitution property of equality, or it's a transitive property. And then finally, we can come to our conclusion. And in math, we have a symbol for the word therefore. And it looks like a triangle without sides, 3 dots. That means therefore, so we come to our conclusion. And now we can say the measure of angle W equals the measure of angle Y if we eliminate these x's on both sides. So the measure of angle W equals the measure of angle Y. So we just proved that since we have linear pairs, vertical angles are congruent. And the reason for that last step, subtraction property of equality. Okay, number 2 says, given the diagram to the right, prove that the measure of angle W plus the measure of angle X plus the measure of angle Z equals 180 degrees. Make a plan first. What do you know about angles X, Y, and Z? So they give you a hint. So you would say the measure of angle X plus the measure of angle Y plus the measure of angle Z equals 180 degrees. Reason? Okay, the sum of the angles of a triangle is 180 degrees. Triangle sum theorem. All right, step 2. Then what can we say? We know that x plus y plus z equals 180 degrees. Now we can say the measure of angle y equals the measure of angle W. So we're saying this angle and this angle are equal in measures, are congruent. And the reason? Vertical angles are equal in measure, or we can say vertical angles are, if you don't want to say equal in measure, you can say are congruent. Okay, so have we done enough to now prove that the measure of angle W plus X plus Z equals 180? And the answer is yes. So now I can say, therefore, the measure of angle W plus the measure of angle X plus the measure of angle Z equals 180 degrees. Okay, so let's recap this. First we said X plus Y plus Z is 180 because of the triangle sum theorem. Then we said W is congruent to Y because they're vertical. So now we can say the measure of angle W plus X plus Z equals 180. So we have W replacing Y. So let me just point this out to you. Here is the measure of angle X. Here is the measure of angle X. Here's the measure of angle Z. Here's the measure of angle Z. Y is equal to W. So instead of saying Y here, we put W in its place. That's substitution. Okay, substitution property of equality. We proved what they asked us to do by doing the triangle sum theorem and vertical angles theorem. Okay, the next one says, given the diagram to the right, prove that the measure of angle W equals the measure of angle Y plus z. Okay. So we're proving that this angle here equals y plus z. Oops, that's messy. And I'm using different number of arcs for each angle because I don't want to say they're congruent. I could put this here because we know x is congruent to y, so we use one on each because they're vertical angles. Okay, so what are we trying to do? We're trying to prove that this angle here is equal to this plus this. So the first thing we're going to do, and I like to color code my steps. All right. What do we know about exterior angles? We know that the measure of angle W equals the measure of angle X plus the measure of angle Z. Okay? X plus Z equals W. Reason? The exterior angle of a triangle equals the sum of the two opposite interior angles. Okay, so that's done. Now what? What else do we know? We know the measure of angle X equals the measure of angle Y. X equals Y, and the reason, vertical angles. Okay, vertical angles are equal in measure. All right, so do we have enough to finish? That's the question. So here's what we're trying to prove. W equals Y plus Z. W equals X plus Z, but X equals Y, so yes we do. So now I can conclude, therefore, okay, the triangle looking dots, now I can say the measure of angle W, so I'm just rewriting this, equals the measure of angle Y plus the measure of angle Z. So let's explain why. Here's W. Here's W. It's equal to X plus Z. We knew that from the exterior angle theorem. But then we said X equals Y because they're vertical angles. So if X equals Y, we can take X and substitute Y in place of it. That's substitution. Okay, so the substitution property of equality says that the measure of angle W now is equal to the measure of angle Y plus Z. Okay, page 3 brings us to exercise number 3. Hopefully you try this on your own. Pause the video, see if you can do these, and then come back and check. Okay, so number 3 says in the diagram to the right, prove that, so I'm going to label this up a little bit, the measure of angle Y plus the measure of angle Z is equal to the measure of angle W plus the measure of angle X. That's what we're trying to prove here. So what I've done is I've drawn two triangles, and I'm going to pull them apart, explode the diagram, so we have these two triangles. So notice what just happened. Here's angle A right here. I'm going to move it over here. So that is still considered angle A. So this is A. And if I do the same with this blue triangle and put it back, this is angle A. So if I move it down, okay, this is also angle A. So we're trying to prove that these two angles add up to these two angles. So the first thing I'm going to say is, I'm going to focus on one of the triangles. Let's do the big one first. The measure of angle A plus the measure of angle W plus the measure of angle X equals 180. Okay, and the reason? Okay, the sum of the angles of a triangle is 180 degrees. Okay, well now let's focus on the red triangle. So that was the first one. And now the red triangle, and actually let me change this to blue, because that's our blue triangle. Now let me focus on red. So now the red triangle is right here, A, Y, and Z. So now I can say the measure of angle A plus the measure of angle Y plus the measure of angle Z equals 180 degrees. And it's the same reason, so just to save time, I'll do this. The sum of the angles of a triangle is 180. So now when I look at these two equations, what do they have in common? A. So if you eliminate A from both, then the other two have to add up to the same amount. So I'll show that in an equation. So I'd say the measure of angle A plus, well, let's just do it this way. Let me keep the colors. The measure of angle A plus the measure of angle W plus the measure of angle X equals the measure of angle A plus the measure of angle Y plus the measure of angle Z. All right. Okay, and that is the substitution property of equality. So I just said, well, if this is equal to 180 and this is equal to 180, let's substitute this piece in for 180 down here. Basically the transitive property as well. And now we can conclude our proof. We proved that the measure of angle Y plus the measure of angle Z equals the measure of angle W plus the measure of angle X. And how do we do that? Well, these two equations are equal, and we subtracted A from both sides, thus eliminating them and giving us measure of angle W plus X equals measure of angle Y plus Z, and I put them in the order of what the question was asking. That's why they're flipped over, and the reason is the subtraction property of equality. Okay, number 4. In the figure to the right, segment AB is parallel to CD. So let me just color code this for you just to make it pop. Here's AB, here's CD. They are parallel. And segment BC is parallel to segment DE. Like so. So the two blue line segments are parallel, the two red segments are parallel. They want us to prove that the measure of angle ABC, which is right here, is congruent to the measure of angle CDE, which is right here. Okay, so now we're starting to put the process of proofs together. So I'm going to set it up a little bit more detailed now. I'm going to do like a 2-part. And on one side, I'm going to put a statement. Actually, might as well make that in black. So this side I would call it statement. Okay, statement and reason. All right, so now we want to prove that these two triangles, or these two angles, are congruent. So you always start off with what they gave you. So I would say segment AB is parallel to segment CD, and segment BC is parallel to segment DE. Reason given. Okay, they gave us that reason. Okay. So now when I look at this line is parallel to this. BC is a transversal. These here are alternate interior angles. So I'm going to say the measure of angle A, B, C, measure angle A, B, C, this angle here, is equal to the measure of angle B, C, D. Because this is a transversal, and these are alternate interior angles. And so therefore the reason is, when two parallel lines are cut by a transversal, the alternate interior angles are equal in measure. Okay, so when two parallel lines cut by a transversal or alternate interior angles are equal in measure, which is the reason for this. So, okay, so now we have this angle here equal to measure angle BCA. So these two are congruent. And now if I focus on BC and DE being parallel, and DC is the transversal, now I can say angle BCD is congruent to angle CDE because they're alternate interior angles. Yes? Okay. So let's do that. Let's see. Let's do blue. So the measure of angle BCD plus the measure of angle, not plus, is equal to, so BCD equals CDE. And the reason, same, so I'm just going to do this. Paste, copy, paste, put this here. And then I'm just tidying this up by giving it a segment in between, so we're making a nice table of reasons, statements and reasons. All right. Oops. Okay, so we now know that ABC is congruent to BCD. We know that BCD is congruent to CDE. So now we can substitute because we have what we're trying to prove, which is the measure of angle ABC equals the measure of angle CDE. Because these two are equal, we can substitute the measure of angle ABC equals the measure of angle CDE. ABC equals BCD. BCD equals CDE. Where's my C? I got angle but no C. There. Angle CDE. That's an angle symbol. Let me clean that. Angle CDE. Okay, so the reason for this is substitution, property of equality. Okay, and there is what we call a two-part proof. Statements and reasons. Boom, boom, boom. Number 5, in the figure to the right, prove that the sum of the angles marked by arrows is 900 degrees. You need to write several labels in the diagram for this proof. Okay, so I copied my statement reason table like so. All right. And now I'm going to begin. So it says we need to label several things in the diagram. Okay. So the first thing I'm going to do is focus on one of the vertices. And I'm going to call this A, B, C, and D. I'm going to name those 4 angles. That's that many degrees. A degrees, B degrees, C degrees, D degrees. And then over here I'm going to say A plus B plus C plus D equals 360 degrees. Reason? Angles at a point sum to 360 degrees. Okay, so now that you know that, let's do the same for the next 2. So let me change the color to green here. And now I'm going to go in alphabetical order, A, B, C, D. And now I'm going to say E, A, I turned you to green. E, F, G, and H. Okay, so now we're going to say E plus F plus G plus H equals 360 degrees. Reason? Same. Angles at a point sum to 360. Okay? Well, guess what? We have another vertex over here. Another vertice. Going in alphabetical order, E, F, G, H. I, J, K. I'm going to avoid L because it looks like a 1, M. We don't like using L in math. I really don't like using I because you'll be learning next year in Algebra 2 that I is a number, but I'm not going to say any more about that now. So anyway, I plus J plus K plus M equals 360 degrees. And you guessed it, same reason. Angles at a point sum to 360. Okay, continuing on. We can now say they all add up to something. So I'm going to color code this again. So now I'm going to say A plus B plus C plus D plus E plus F plus G plus H plus I plus J plus K plus M equals 0 plus 0 plus 0 is 0. 6 plus 6 is 12 plus 6 is 18. Carry a 1. 3, 6, 9, 10. So those 3 vertices add up to 1080 degrees. Now let me just move my table over like so. And let me shorten this segment so it's not in my diagram and move these over here. Actually, I could just move everything down. Let me do that. I don't want to be in my diagram. So let's move everything down over like so. And then these, I'm just cleaning this up so that I'm not in my diagram. So if you started this, that's fine. We just don't want, I want things to fit better. Alright, we'll get this in a minute. Let me pause it so you don't have to watch this paint. Okay, so now we have A plus B plus C plus D plus E plus F plus G plus H plus I plus J plus K plus M equals 1080 degrees. That's all of these. Reason. Okay, there's a misprint. Addition property of equality. Put that little E there. Addition property of equality. Okay, next step. Now look inside the triangle and we have C, H, and I. So now I'm going to say C plus H plus I equals, well, what do these three angles equal? They're inside a triangle, hint, hint, 180 degrees. Okay, so now we'd say the sum of the angle measures in a triangle is 180 degrees. So C plus H plus I equals 180. All right, so now we're going to focus on the outside of the triangle. What three angles are out here? In other words, what angles did we not use when we used C? A, B, and D. So I'm going to say A plus B plus D plus, then go to the next vertex and don't use H. We're not using these three. The other three are E, F, and G. So plus E plus F plus G. Go to the next vertex. And we have I, J, K, M, but we're using I here, so we're going to just be the exterior, J, K, M. So we have A plus B plus D plus E plus F plus G plus J plus K plus M. Well, what did we eliminate? We eliminated C, H, and I, but we already know they're equal to 180, so I'm going to put them back by just saying plus 180 degrees equals 1080 degrees. Hopefully that made sense to you. Here we're saying C plus H plus I is 180 degrees. We took C out of this piece, we took H out of this, and we took I out of here. So removing those three that add up to 180, and we put 180 in place of them, it's still equal to 1080 degrees. And that is substitution. And I believe now that we have enough information to come to a conclusion. And let's use orange. So I'm going to say how do we put this all together? Well, now we're going to say A plus B plus D plus E, and so on and so on. So we're going to say A, pen, plus B plus D plus E plus F plus G plus J plus K plus M equals, subtracting 180 from both sides, we get 900 degrees. So it says, prove the sum of the angles marked by arrows is 900 degrees. So the arrow marks are the exterior, these three, A, B, D, E, F, G, J, K, M equals 900. So we just proved that, and the reason is the subtraction property of equality. We subtracted 180 degrees from both sides and proved that the exterior angles around this triangle add up to 900 degrees. Okay, page 4 brings us to problem number 6, and it says in the figure to the right, prove that DC, this line segment here, is perpendicular to EF, meaning at this location here, they intersect at 90-degree angles. Okay, so I have my statement reason table. I have two triangles. So here's one. Actually, I have three triangles. There's one. Here's one. So there's two of them, and then there's this little one in here. So I'm just going to focus on the blue one first. this is 60 degrees because of here. This is A, this is E, and this is F. And this is 60 degrees. So now we can find the measure of angle F, but I can't just call it angle F in this diagram. I can down here because there's only one angle at this vertex, but down here there are two. So angle F could be here, or angle F could be over here. So whenever that happens, we have to use three letters to name them, which is what I will do. So what do we know? Three angles in a triangle add up to 180, so the measure of angle A plus the measure of angle E plus, now use three letters, the measure of angle EFA equals 180 degrees. Okay, well, why is that? Why is that true? Reason, let me move my triangle down here out of the way. That's 60, that's 60, that's E, that's F. Okay, reason for this, well, you know that by now. Okay, the sum of the angles measures in a triangle is 180 degrees. Okay, there's step one. Now let's do the same in the red triangle. So let me switch to red. So this is C, this is B, it's labeled as a 90-degree angle. This is D, and C is 60 degrees. So again, I would say the measure of angle C plus the measure of angle B plus the measure, now down here I could just call that angle D, but up here I can't because I have an angle that's on this side and I have an angle on this side. D could be either of the two, so we need to be more specific by using three letters, and I'll call it CDB. And they equal 180 degrees, and the reason, same as the last. The sum of the angle measures in a triangle is 180 degrees. Okay, next step. So now I know that these two triangles have a sum of 180 degrees. Now let's make some conclusions about that. Now, since the measure of angle A plus E plus angle EFA is 180, and we know that E is 60 and A is 60, then the measure of angle EFA must also be 60 degrees. Why? 60 plus 60 plus 60 is 180. So down here I can say the measure of angle EFA equals 60 degrees. And the reason is subtraction property of equality. So if we subtract 120 from both sides, we get the measure of angle EFA equals 60. Now we're going to do the same for the red triangle. So now I would say the measure, well, actually let me draw another segment here, separating the steps. Okay, all right, now I'm going back to the red equation. So if this plus this plus this equals 180, then the measure of angle CDB equals 180 minus 90, which is 90, minus 60, which is 30. So the measure of angle CDB equals 30 degrees. Reason? Subtraction property of equality. Let me extend this down. Draw another line. Okay, so now I can write in my diagram, always label your diagrams, this is 30 degrees. Now I can say, well, Draw in label Z. See what that says right here? So I'm going to call this angle, this point right there, Z. Now I can say angle EZ, or DZF, let's call it that, the measure of angle DZF equals 90 degrees. Okay, can we do that? Just a moment. Okay, let's not say this right away. I'm jumping to conclusions. I'm skipping. All right. So what we want to say here is, notice we said 3 angles in a triangle add up to 180. And then we said the missing angle. 3 angles of the red triangle add up to 180. And then we said the missing angle. Well, if I do the same with this little triangle, so I drew that orange. So if I bring this down here, all right, so this is 30 degrees, this is 60 degrees, so therefore this is 90, and this is D, and this is F, and this is Z. Okay, so now I can say the measure of angle CDB, right here, the measure of angle CDB plus the measure of angle F, which is EFA, plus the measure of angle DZF, or DZF, yes. Oops, I forgot my measure angle equals. Alright, measure of angle DZF equals 180 degrees. Reason? The sum of the measures of an angle of a triangle add up to 180 degrees. Okay, so now that I've said that, let's see. Now I can say, so we're talking about DZF, which is right here. So now I can say this is congruent to this. And actually I can say, since CDB plus EFA plus DZF equals 180, and I know the measure of angle CBD is 30 degrees, right? And EFA is 60 degrees, then I now know that DZF is 90 degrees, right? Because 30 plus 60 plus 90 is 180. So I know DZF is 90 degrees, and now I can say the measure of angle DZF equals the measure of angle EZC Reason, let me just write it. Vertical angles are congruent. So now I know that this is 90 degrees. So instead of having all this mess here, let's just do this. Okay, I need the Z there, EZC is 90 degrees. All right, so now finally I'm going to say, since EZC is 90 degrees, can we prove DC is perpendicular to EF? And yes, I can. So now I can just simply say segment DC is perpendicular to segment EF. Reason. Perpendicular lines form 90-degree angles. Okay, page 5 brings us to the end of lesson 9, our introductory to two-part proofs. Go do your problem set.